In this video of SolidWorks Plastics, I will show the different types of mesh you can apply to your part and additional meshing options. Begin by going to the Plastics Manager tab, and under Mesh, right-click on Shell, then pick Manual. Click on the Next button. You can drag this slider along to increase or decrease the size of the triangles. You can also manually input this number here. This will then predict the amount of triangles in your mesh. Select Auto for the local refinement, and then drag the slider along for gradation. Click Mesh. This will then show you your mesh. As you can see, the triangles are smaller along fillets and holes. This is due to the local refinement you checked earlier. Click Next. This will give you a summary. Click OK. Double-click on Delete Triangle. Then zoom in on your mesh. Click on a triangle you want to delete. You can also drag over an area of triangles you want to delete. Then click Apply. Go back to the Function Tree tab and double-click on Subdivide Element. Pick triangles you want to divide in smaller ones. Choose the density and then click Apply. Click OK. You can also insert a node by double-clicking on Insert Node. It will then insert a node in the middle of the triangle where you have clicked. Click OK. When you're done, click OK and your mesh will be complete. Now, to create a solid mesh, right-click on Solid and click on Manual. Then click on Next. Click Yes to copy the parameters over from the previous mesh. Click Next. As you can see, the triangle size, the number of triangles, the local refinement, and the gradation have carried over from the previous mesh, so click on Mesh. And if you zoom in, you can see the smaller triangles that are created due to the local refinement. Click Next. This will give you a summary again, and then click OK. Click on Next. Then you're given an option for tetrahedral mesh or hexahedral mesh. Pick the tetrahedral mesh, and then click on Next. For the parameters, choose Hybrid for the best results. You can also slide the gradation slider along. Check the box for the minimum thickness of boundary layer elements, and then click on Transform. This will show you a preview of the mesh. These are the boundary layer element thicknesses. This shows how the boundary layer element thickness affects the mesh. They also affect the amount of calculations done during the analysis at the surface. Click on the Next button. Then click OK. You will now have completed your mesh. I will now show you how a hexahedral mesh is different. Pick hexahedral mesh and then click Next. Enter 2 for the size, and then click on Transform. As you can see, this mesh is not ideal. To improve this, you can reduce the size. And now it is better. Here you can see the analysis results on the shell and solid mesh. As you can see, there's not much difference because the part is very thin. However, here when the part is very thick, you can see that the shell mesh is not very accurate. The solid mesh types are far more accurate, with the tetrahedral hybrid solid mesh being the best. When you are opening a part with two meshes, you'll be asked which mesh to choose from. This will display your results accordingly. I hope you found this video helpful.